But guess what? That happens in the onload event. And in most cases, the user's not going to wait for the onload event for this page. After 19 seconds or 15 seconds, or if you're like me, a second and a half, you're going to hit reload, right? And so anyone who's relying on RUM to keep track of these front-end stalls, you're missing the slowest times that your users are experiencing if you're waiting for onload. So a simple thing to do there is if you're doing any kind of RUM instrumentation monitoring metrics on your page, have a timeout. Maybe keep the onload code there, but also after about 10 seconds, you might want to send a beacon back that said, this page, it's been 10 seconds and it still hasn't loaded, but I'm just letting you know it's been over 10 seconds. You might know from looking at your stats, what a good abandonment point is. 10 seconds, 15 seconds, 20 seconds, 5 seconds. So why did this happen on Business Insider? Is that readable? Can everyone gather in the front, right in front of the slides? Actually, I was telling Doug I have my first pair of reading glasses. We could pass these around. No? Okay. All right, well, I'll tell you what it says. So this is the Business Insider code. I have to put my glasses on. I'm joking, that makes it worse. This is the Business Insider code, and here you can kind of see, well, actually you can't. If you could read, you'd see that there's a comment in green up above that says Quantcast. So Quantcast is a metrics logging sort of company, and so they're inserting the Quantcast JavaScript file, but they're using it using this async pattern, insert before. So they have a JavaScript object, and they're inserting it into the DOM, and when you do it that way, it's asynchronous. Beauty, beauty. Business Insider off to a good start. Here's another one. This is the Google Analytics beacon. I think this is one of the first beacons, big popular beacons that, or snippets that came out asynchronously, and they've kind of set a pattern that most people are following in the industry now. And it's the same thing. They are using this technique where they queue up commands and then they load the script asynchronously. And here's a third one that's done asynchronously. This is KISS metrics. Really don't know what that is. But they're loading it asynchronously with this insert before pattern. So how did we get this stalled page that took 20 to 120 seconds? Well, it turns out there's a lot of scripts. There's like 50 scripts on this page. Maybe not 50, okay, 30. And here's one of them. It's the Twitter anywhere.js script, and it's loaded synchronously. Script source equals blah.js. And when that happens, the browser's going to stop there and not render anything else below that script tag. And guess what? This script is in the head, so the entire body is being blocked from rendering by this script. Now, how is it that it's timing out? It's taking 20 to 120 seconds. I first noticed this and wrote the blog post, so that's a failure. And this is something I call front-end SPOF, and that name has kind of caught on. You can read that blog post if you want. So, the way I discovered this is kind of interesting. I was in Beijing last December for Velocity China, and I loaded, because I'm so impatient with time, I have this script that I fire up in the morning. I click go, and it loads the 30 web pages that I read every morning. And while they're loading, I go and get my breakfast. And I bring it back to my desk, and by the time I get back, those pages are loaded. And I don't have to wait for any of them. So it's like a dagger in my heart, watching these websites load so slowly. And so in the morning, I run the script, and Business Insider, by the time I get to it, it's blank. I'm like, well, why is it blank? And I noticed that, so I fired up a packet sniffer, and I noticed it was because of the Twitter widget. So when I got home and I decided to write this up, I needed a way to reproduce that. And that's where web page test comes in. So actually I did mention it as part of the talk. So I'm using web page test, and I'm going to businessinsider.com, and here's the failure that we see. The rendering is blocked. This is called film strip view. There is no painting on the page until about sometime after 20 seconds. And that's because this Twitter script, and I'm in IE, which times out after 20 seconds. So no rendering happens for 20 seconds. And the way I was able to reproduce this using web page test is they have a web page test instance in China, which is behind the firewall, which blocks twitter.com. So anyone who has users in China and is using any of these widgets that are blocked by the Great Firewall, Google, by the way, is blocked, you might want to look at your page load times in China, because I bet they're over 20 seconds. And I think WebKit is even longer than that. I also noticed Radar. O'Reilly Radar had a similar issue. So I then went and looked at the Twitter code to see who was really to blame here. For example, Google Analytics is asynchronous, but we still publish, we still document the synchronous version in case people want to ruin their website. And here's the documentation. I love Twitter, but here's the documentation. A blocking script. They tell you to put this blocking script in the page, and look, it's in the head. So it's going to block the entire body if it's ever blocked by a firewall, or if it's just slow. Like, you know, like, it's not implausible that the Twitter script could take 3 seconds to download, on some occasions 4 seconds. Do you really does Business Insider want their entire page blocked for this Twitter widget, which is this big on the page? No, it's ridiculous. So, yeah, and it's in the above body, so the entire body is blocked from rendering. I think I'm going to be sick. Okay, so that's why we have this behavior. The entire page is blocked for over 20 seconds. Now, how unusual is this? So, I don't spend much time in China. We don't have a firewall here, or at least not a government one. You might have one at work. So I run this side project called the Hcp Archive, where I crawl hundreds of thousands of URLs a couple times a month and gather information about how many scripts they have, how many bytes they have, how fast they load. And I ran this query, and I thought it'd be good to go through this query line by line. So we'll do that. I want to find URLs. So my goal is I want to find some other instances of this front-end SPOF. So I want the URL, and I want the web page test ID that will take me to the results so I can look at them. From my two tables, I have a table of just the high-level page information and then all the resources or requests that that page contains. And I want to bound those to be a specific run. I think this was in May, the run May 1st or May 15th. So the page IDs were in that range. And I wanted to find some fairly popular sites, so I picked ones that were ranked in the top 20,000 worldwide, where they had at least one request, one response, whose content type contained the word script, and its load time for that one resource was over 10 seconds, and the rendering of the page was also over 10 seconds. And I'll group those by page ID. All right, that really wasn't that enjoyable. And there weren't any pretty photographs in the back of the slide. But the point is, all of the Hcp Archive code and data is open source. You can download it all and have an instance of your own running in probably a couple hours. And then you can run your own queries like this, and you can slice and dice this data any way you want. And there are people around the world who care about performance who are doing stuff like that. So it wasn't super fun, but it's pretty easy once you learn about the schema. And so I found these examples. Here is, this is Beta Brand. For some reason, they have this script from Facebook that I don't know why the internet is not deterministic. You know, this Facebook script took 14 seconds to download, and it blocked the entire page from rendering for 14 seconds. This is Big Follow. I think it has something to do with SEO or something like that. And here they had scripts from apis.google.com and Facebook that for some reason took over 25 seconds to return. And so the rendering was blocked for 25 seconds. This is, I can't even read it, like cool? Cool? Oh, like cool. Yeah, man. And they have a glam.com, which is the industry leader in some type of media advertising, but they are not the industry leader in high-performance scripts. And so here their script is taking 15 seconds or something like that, and it started a little late, so it blocks rendering until about the 25-second mark of the entire page. Look, this is what kills me, is it might be hard to read, but you know, this is a waterfall chart, and each of the rows of the waterfall chart is a request. The first one is the HTML document, then you have a bunch of scripts and images and style sheets and other stuff. So there's like 15 requests that have already been downloaded. Images, scripts, the whole HTML document, all of the text in the HTML document is in the browser right now, and none of it is being drawn, waiting for this one glam script, which is request number 17. It just doesn't make any sense. It's madness, I tell you. And this is buckle.com, and they've got, for whatever reason, you know, in this test, Facebook, Twitter, and Core Metrics all took a long time. And just to be clear, I'm using web page test, my own private instance of web page test. These, and I'm using IE, and these IEs are running on PCs that I own, and they're running on my network. And so, you know, 99.9% of the 300,000 URLs I'm churning through don't have issues like this.